So let's do a brief recap of the two-body motion. You have that in this orbit here, this plane orbit. The planet is here at point P, going around in its elliptical orbit. You can specify this orbit by the semi-major axis, which is the distance from the center, the geometrical center of the orbit in the line of apsides to either perihelion or aphelion. The eccentricity, which is the distance from the center of the orbit to the focus in units of the semi-major axis. The true anomaly is the angle from pericenter to the position of the planet with vertex at the focus. And in this case here, we align the line of apsides with whatever coordinate system we are using. If that wasn't the case, if you use another coordinate system, then you have the argument of pericenter, which is this angle omega, which is the angle between the line of apsides and whatever is the coordinate system that we are using. And if you have inclination, you have a planar reference and you have an inclined orbit, then you have extra orbital elements, which is the inclination. Now you have the longitude of the ascending node, which is measured from the reference distance, which is usually taken to be the vernal point. That's the angle then from this reference line to the ascending node, which is where the orbit intersects the plane of reference. You have two nodes where this intersection happens. This is the line of the nodes. This is the ascending node where the planet is going up, and the descending node where the planet is going down. So these 6 parameters, the semi-major axis, the eccentricity, the inclination, the longitude of the ascending node, and argument of periapsis, and the true anomaly define the orbit and the position of the planet in the orbit. Right, so these are the elements of the two-body problem.